Welcome back. We're in lesson 113 and we're going to talk about direct variation first. Suppose that in every classroom of a particular school there are twice as many boys as there are girls. So we could write a formula that represents that. We could say that the number of boys equals 2 times the girls, right? So we could also say in another school that the number of boys is 3 times the amount of girls. Okay, when we have this type of a situation, this is what we call our constant. It is our rate that determines everything. So if we know the number of boys, we can divide by 3 and figure out the number of girls. If we know the number of girls, then we can multiply by 3 and get the number of boys. So this constant is the relationship between these two variables. And we usually write that as the letter K, lowercase k, that equals what we call a constant. And we use that letter K whenever we have a problem that says something along the lines of something varies directly to something else, or something is directly proportional to something else. So, for instance, if I make the statement, the weight of a substance varies directly as the volume. Every time you hear varies directly, you would write equals K. So equals K is varies directly. All right, you use your constant for varies directly as a factor, right? This is a factor. These two multiply. So it is a multiplication problem when something varies directly. You could also write that as, with this statement, force varies directly as the current. The distance traveled, distance, varies directly as the time. So you see how every time I say varies directly, I write equals K. Well, there's another terminology that you could use for that, and that is directly proportional. Those two phrases mean exactly the same thing. I don't know why I'm trying to write direction. Directly proportional. So varies directly or is directly proportional means exactly the same thing. They are synonyms. So when you hear those two phrases, you're going to write equals K. So here's some directly proportional statements that you might hear. The circumference of a circle is directly proportional to the radius, right? And we know that it is. We know that when we do the circumference that we have to take into account the radius in the formula. So it is directly proportional to that. Also, the volume of a right circular cylinder of a fixed radius is directly proportional to its height. And we know that's true too. When you take the base, you multiply it times the height, and that gives you the volume. So the height is directly proportional to volume. Okay, so anytime you hear varies directly or is directly proportional, you write equals K. And K is your constant. So let's try some problems. But first, take these notes down. You can pause and write this down in your notebook if you haven't been writing along with me. Okay. I'm going to clear this and we're going to do some problems with direct variation. All right, 113.1. So listen carefully to what I say. The mass of a substance varies directly as the volume of the substance. All right, there's our formula. The second sentence says this: if the mass of 2 liters, okay, now listen, the mass of 2 liters is 10 kilograms. All right, 2 liters, liters is volume. Okay, this is a prepositional phrase. So you take that out. The mass is 10 kilograms. So it pays to know a little bit of grammar when you're doing word problems. Okay, the mass is 10 kilograms. Of what? Of 2 liters. That's the volume. So we put 10 in for the mass, and we have our constant K, and 2 is the volume. All right, now all we do is we divide by 2 on both sides, just like you normally would when you have a number and a variable. 5 is your constant. So we take 5 and we put it into our formula. So M equals 5 times the volume. Mass is 5 times the volume. Okay? And if you look at this, the mass is 5 times 2. So the mass is 10 kilograms. The volume is 2 liters. 5 times 2 is 10. So this statement is true. We have our correct formula. But now it's going to ask us a suppose question. And it's going to say, if the mass of 2 liters is 10 kilograms, okay, and that's what we have figured out here, what will be the volume of 35 kilograms? So we have to figure out the volume of 35 kilograms is the mass, right? So 35 equals 5V. We just divide and we find out that 7 liters is the volume, because the volume unit of measure here was liters. So that's what we'll do. So that equals liters. And you could just write that out to the side somewhere. Or you could just say 7 liters in your answer. I don't care. As long as you get the right number and you try to get the right unit of measure, I will, work with you on that and help you understand what it should be. All right, that wasn't that difficult. It's all about understanding what you are reading and knowing a little bit about, what these things are. Okay, if you know that a liter is volume, and you know that a kilogram is a weight, and you know from chemistry or physics, mass is weight. Mass is not volume. It has to do with the weight of something. All right, let's do 113.2. All right, 113.2 states this: the distance traversed by a car traveling at a constant speed is directly proportional to the time spent traveling. Okay, doesn't that look like dirt? D-I-R-T? Yes, okay, our constant is standing in for rate, right? All right, so we can recognize that formula. We know what we're getting. Now it gives us some information so we can figure out what our rate, our constant K, is. If a car goes 75 kilometers, that's a distance, so we can put 75 here, in 5 hours, how far will it go in 7 hours? So first we have to figure out our constant, okay? And we just divide both sides by 5. And that gives us 15 equals K. So now we can sub in 15 for K in our original problem. So D equals 15 times T. Now we're asked, okay, well, if this is true, how about 7 hours? 7 hours is the time. So the distance is going to equal 15 times 7. And that's going to give us how many kilometers? And 15 times 7, that's going to be 105 kilometers. Easy peasy, right? This is easy peasy. It's all about understanding what you are reading. Pay attention and don't be afraid to cross out prepositional phrases that can be distracting, because you need to know the subject and is directly proportional to the object. Okay, that's how it works. The subject is directly proportional. The subject is D. Is directly proportional is K. That's your verb. And the object is going to be to the time spent traveling. That's the time. That is your object here. All right. That's the object of the preposition that talks about what is directly proportional. So now let's do 113.3. All right. Under certain conditions, the pressure, okay, of a gas, that's just a prepositional phrase we can get rid of, varies directly as the temperature. So the pressure varies directly as the temperature. When the pressure is 800 pascals, the temperature is 400 Kelvin. So let's figure out our constant. Divide both sides by 400. 2 is our constant. So we can rewrite our formula. P equals 2 times temperature. Pressure equals twice the temperature. Okay? What is the temperature? So this is what we're going to look for. What is the temperature when the pressure is 400? So 400 is the pressure. What is the temperature? We're going to divide by 2, right? So 200 Kelvin is the temperature. That's all we're doing. All right? Easy peasy. Just listen to what is being said and look for your key words. Varies directly or is directly proportional. Those are the 2 words you are listening for. All right, now we are going to flip a switch and talk about inverse variation. So when I say inverse variation, what is the inverse operation to multiplication? It is division. So if I say the volume is inversely proportional to the weight, we're going to use division and not multiplication. So with directly proportional, we had multiplication. Inversely proportional, we're going to have division. So division is inverse. Multiplication when you multiply, it is direct, okay, or directly. All right, think of it like this. The inverse operation of multiplication is division. You'll get it, I promise you. All right, so now we can do some statements. If you were to hear a statement that said, the pressure of a perfect gas varies inversely as the volume. That's what you would write. When you hear varies inversely, you're going to write equals K over something. All right, here's another one. The current varies inversely as the resistance. Right? Okay, varies inversely. Here's another one. The velocity is inversely proportional to the time. So another phrase that you might hear is inversely proportional. Remember, the other one was directly proportional. This one is inversely proportional. And the other one varies directly. This one varies inversely. Okay? So listen for those two words. Inversely is what we're listening for division. All right? Okay. So let's work on an example problem for inverse variation, which means we will divide. Okay, under certain conditions, the pressure of a perfect gas varies inversely as the volume. When the pressure of a gas is 7 pascals, the volume is 75 liters. Okay, so let's figure out what our constant is. Well, before we do that, let's finish the problem. What would be the volume if the pressure is increased to 15? If the pressure equals 15. What's the volume if the pressure equals 15? Okay, let's find our constant first. So how do we find a constant when we have a fraction? How do we do this? We multiply times the inverse fraction, right? So we're going to say 75 over 1 times both sides, right? 75 times 7 is going to be 525, and that's going to equal, these are going to cancel, so K over 1 is just K. So our constant is 525. So we can rewrite this as pressure equals 525 over volume. Now we're going to sub in here. What is the volume if the pressure is 15? So if P equals 15, what is the volume? So we're going to put 15 equals 525 over V. So what do we do when we have, we just use the inverse, just like we did up here. We just invert it. So times V over 525, right? And this is going to be, oh, I'm sorry. V over 1. And this is going to be V over 1. Not over 525. We just take the denominator and make it a whole number, and that's what we multiply by. So 15V equals, these two cancel, 525. So now we just divide both sides by 15, and volume equals 35. So the volume is 35 liters. Right? Very good. All right, let's do one more. Let's do 113.5. Okay, and it says, to travel a fixed distance, the rate is inversely proportional to the time required. When the rate is 60 kilometers per hour, the time required is 4 hours. So what do? We multiply by 4 as a whole number on both sides. So we end up with 240 equals K, because these two cancel. All right, so now we can rewrite this with our constant. So the rate is equal to 240 divided by time. So the question goes on to say, what would be the time required for the same distance if the rate were increased to 80 kilometers per hour? So the rate is going to be 80. So now we have to figure out what the time is. So all we're going to do is we're going to multiply times t over 1 on both sides. Cancels here. So we have 80t equals 240. So if we divide both sides by 80, right, then t is equal to 3 hours. Right? Do we see how we got that? All right. That's all I have for direct variation and inverse variation in lesson 113. I will see you in lesson 114.